In this video, we're going to find the derivative of the matrix function AX. Now, in our book, X is a column vector. So X1, X2 to Xn. So X is in Rn. A, if we're multiplying it by X, has to have n columns, but the number of rows can be whatever, and it'll still work. So A is going to be A11, A21, AM1, A12, A22, AM2. A1n, A2n, AMN. So we've got our A and we've got our X. This is n rows, m rows, I should say, by n columns, which means AX is going to equal, when you multiply these things, you get A11 X1 plus A12 X2, so on, A1n Xn. Then row 2 is going to be A21 X1 plus A22 X2 plus etc. A2n Xn. On the last row, we're going to have AM1 X1 plus AM2 X2, AMN Xn. And so that's what our AX looks like, and we want to differentiate that with respect to X. So we're looking for the derivative with respect to vector X of AX. Now, for our book, we're going to have each row of the derivative representing the rows of AX, and each column the variable to which we're taking the derivative. Okay, so the 1, entry here is going to be function 1, variable 1. So the derivative of the first line with respect to x1 is A11. The derivative of line 1 with respect to x2 is A12. And that happens, etc. Derivative with respect to n is A1n. Okay. If we move down to function 2, with respect to x1, the derivative is A21, then A22, then A2n, and so on. With respect to the m function with respect to x1 is AM1, with respect to x2 is AM2, and AMN is the derivative of function m with respect to variable n. So this is in fact equal to a. And so what we see here is that the derivative with respect to x of AX is equal to a.